Good evening, everyone. Good morning, good afternoon, depending on the time zone where you are connecting. So we are moving straight to the R section for today. So our faculty is in the house. Over to you, sir.
Good morning. Good evening. Can we hear my voice? Dr. K,
Yes, we
can you
can
hear
hear
me?
you.
Okay. So we want to
Yes.
look at the second lecture for week 2. The second lecture is all about data visualization and how we can connect, how we can get data from other sources. So that is what we want to look at today. So how to import data from other sources into R. R itself does not have data storage facilities except for the inbuilt codes to hold data and variables. Unlike Excel, Excel can hold data. Excel is a spreadsheet, it's not a database, but we can actually store data in Excel. We can store data in different formats. These are some of the formats we'll be looking at. We look at CSV, how to get data stored as CSV, as text, as Excel, as JSON, as SQL, and SPSS.
Echo,
So,
please, can you increase your volume, please?
okay, can you hear me now?
Just a bit, increase it, or you move closer to your mic.
Okay,
Go on.
can you hear me? Is
Yeah,
my
we can hear you just to increase it. That's all.
okay?
Now continue.
So, how to import CSV files? I will go straight to the code, but I just want to use this to explain some things before I go straight to the code. The CSV is a comma separated values. It is a text file separated by comma, but we can view it from our Excel. That is one of the best place to view our CSV file. In fact, most of our file will be saving it as CSV. There are three popular methods available to import CSV file into R. We have the read.csv, which most of us use. We have the read underscore CSV, and we have the fread. We look at these three methods of loading files into R. Using read.csv, the read.csv method is used to import a CSV file, and it is best suitable for the small CSV files. The syntax is read.csv. Syntax, for those of us that are learning programming for the first time, syntax is like the way of writing or style of writing a particular program or a language. If you don't follow a particular syntax for a particular language, you might not get it right. Like for instance, for English, if you want to say the boy, the article D comes before the boy. In Yoruba now, we say omo náà. The omo, which is the noun, comes before noun, which is the article, is the other way around. So you must know the syntax of a language before you can actually use it. If you want to import data from CSV to R, you use read.csv. Then you open a bracket, you put the path. The path is actually where the data you want to import is. Then we have the header true. Header true meaning that the first line, the first rows are the header. Then we have the step. You put open quotes comma, meaning that that comma there means that the data are separated by commas. The data are separated by commas. So what are the arguments? That is what I've explained. So for every syntax you see in R, you always have the syntax and the arguments. Sometimes you might want to go online to search for a particular code. And the first thing to look at is the syntax and the argument, so that you know in particular what each of those arguments mean. If you want to use read.csv, the important thing there is the path, but other operators or other functions or other features are also necessary depending on how you want to view your data or how you want to import your data. Note, the difference is that the CSV to read.csv default the delimiter to a comma, while read.table uses tab as its default. Under option of reading file, instead of using read.csv, you can also use read.table at any point in time. Just any CSV file can be read using read.table. Read.table use tab as the separator, while read.csv use comma as the word separator. Then we have read_csv. For you to use read_csv, you might require to install a particular package. Read_csv is just the same function as read.csv. But when the file is large and you discover that your read.csv cannot pull the file, you just need to use read_csv. But at this point, you will need a package to do that. The syntax is here, is read_csv. You put the path, you put the column names, then comma, n name, the maximum number, n max, then the column types, and progress. You have the arguments there. The path is the CSV part that needs to be imported. The advice I will give is that anytime we are running a code from R, it's better you save the scripts and the data in the same folder, so that you don't need to start looking for parts that is not lost. Just type the name of the data and that will be sufficient. But if you don't have the data in the same folder, that is when you start looking for the parts, and make sure you get the part right. Otherwise, the data will not be imported. But just to be on the safe side, just open a folder, put the script in the folder, and put all the data you want to use inside the same folder. So as you are calling up the name of the data, you are getting everything right. So the column names indicate whether to import headers in CSV. By default, it is set to true. So even without putting the column names, it will import it. Then n max, the maximum number of rows to read. That is the maximum number of observations that we have in the CSV file. Then column types, if any column succumbs to null, then the column type can be specified in the compact string format. Then we have the progress meter to analyze the percentage of files read into the system. You can actually know the percentage of file read into the system, especially when you are dealing with large file. Then for the using of fread, I'm just going through this so that by the time we go to the script, we'll not be going front and back, because I just want us to have the script, but I'll just go through this so that anytime you go online to get a particular code, since you will check out for. Then if the CSV file are extremely large, we started from large, very large, and extremely large. If the CSV file is very extremely large, the best way to import them into R is using the fread method. So we have to install that data.table package. Then we can use the syntax. The output of the data will be in form of a data table instead in this case. So the first thing is to import the data table library. So once you import it is not enough. Loading the package is not enough. You have to also call the library for you to use the package. So you can also import data from Excel. If we import data from Excel, we'll be looking at this Tesla debt and data, how you can import it from to Excel. So the syntax is read underscore Excel, and you have the file name, and we have the sheets that the data is starting from sheet 1, and the header is 5, and importing data from a JSON file. You can also have the syntax and so on. But the important thing I want to show us from this PDF, because the actual work will be done from the script. The actual thing I want to, you can also import from SQL and so on. But the major thing I want us to do right now before we go to our file is to see how to visualize data. So data visualization, we also have the syntax for data visualization. We have the arguments, like for example, for bar charts, you have the bar plus, the keyword there is bar plus, then open bracket, X is your the value you want to look for the bar chart, you want to plot the bar chart. Then you have the X lab. The X lab is the label for the X axis. Y lab is the label for the Y axis. Main is the label for, is the title of the bar chart. Names.arg is the label on the row. While the color, and the color is the color you want to give the bar chart. So what is important here is just the bar plot X, or bar plot the variable you want to plot the bar chart. You know, X now is not the entire data. It's just a particular variable in the data set. So when you do bar plot, that variable, it will give you the bar chart. And if the data you want to plot and nominal, there are values like string, maybe male and female, you have to factor it or table it to see the frequency, the number of male, the number of female. Then you can factor it then before doing your bar plots. So I will show you all this when we get to the script on how to use bar plot. The major arguments in bar plot here that is different from other plot is the names.arg is specific for bar plot. Your S label is the same for other plots. Your Y label is the same for other plot. The main, that is the title, is the same for other plots. Color COL is the same for other plots. So names.arg is just a vector of names appearing under each bar. At least for everything you know, or for everything you want to do in R, I always want people to have a little understanding of what they want to achieve. You can just go and Google what bar chart is, or from your previous knowledge of statistics, just try to see what you want to achieve in R. How do I achieve it ordinarily? Or what does it mean? When you say bar chart is actually a chart, because the size or the width of the bar is not measured to scale, but the height of the bars are measured to scale. That is, the frequency are measured to scale. But the name, those name appearing under each bar, or the label appearing under each bar. So the bars, the width of the bars are not measured to scale. So bar can be in column form or in row form. All those are things you are going to look at for. We have the pie chart. Pie chart also has its own argument. We have the pi, X, we have the label, we have the radius, we have the mean, we have the color, we have the clockwise. So all these are the arguments. The label is used to give description to the slice. So you can use the percentage as label. You can also use those the actual name of the label as label. The radius indicate the radius of the circle of the pie chart, and it ranges between -1 and +1. Then we have main, indicate the title of the chart, just like the main in the bar chart. We have the color, just like the color in the bar chart. Then we have the clockwise. which is not an argument in the bar chart. It's a logical value indicating if the slices are drawn clockwise or anti-clockwise. So to visualize now, this year I'm going to want to look at how to visualize spatial data in R, especially those people that are in geoinformatics that use data, online data, especially the map, Google Map. For you to have access to Google Map, you quickly do this so that by the time we start the practical aspect, you don't have issues. We have installation of ggmap package. For you to use the ggmap, you can install the ggmap from your Army Direct, but for you to use the ggmap, you have to do the following things you are going to look at. By the time we install the ggmap, we can draw map from scratch. We can also look at advanced topics in map visualization like the geocoding, the reverse geocoding, the drawing of routes, and calculate the distance between locations. We have two towns, Lagos and Ibadan. You want to see distance between Lagos and Ibadan. Or you want to see the distance between Lagos and Abuja. You can actually do that. Then how do we do that? The first thing is to have an active Google Cloud Platform account. Yes, otherwise you not have access to the Google Map. So you click on the Google Cloud Platform. It's an hyperlink. It will take you somewhere. Try to follow it and apply. It will ask you to put your credit card information. Yes, put them. Don't worry, it won't charge you any penny without your knowledge. You can use it for the first 3 months. After the first 3 months, it will not ask you if you want to do the paid version. If you want the paid version, if you have the money, of your company has the money, you can do the paid version. But if you don't have the money, at least you can use it for this period as for free. But you must need all those information to open it. So if I click, for instance, if I click on Google Cloud Platform, if you want to link me up to the platform, you say get considering build and transform with Google Cloud. You can go to get started and click on it and just follow it. Let's see as many people that can do that, and make sure you do that. But if you did not get that, that is the only part of the lecture you are going to miss. Subsequently, when you have the video, you can do that. If I say get started, you should open this and you follow it. I've already done it on this system, so I might not do it again. So it will show you. You can close all this and you just go straight to it. Let me go back to I would have opened.
Echo, sorry.
Sir.
Can we please start from the bar chart and some of those things first before the cloud?
Coming to this one.
Yes.
Okay, sir.
Thank you, sir.
Okay, sir. So let me share my scripts. Share. Okay. Let us open. I believe by now we have those things downloaded on our system, the data we are going to use for today, and the script. If you want to open the script, you go to File. Know the location of the folder where you have saved the work. You create a folder. I believe by now you should know how to create a folder where you put the scripts, the data. So for you to do that, just to open the folder, you click on Open File. This is my own. I put my own under data analytics class. So I have to locate it. This is lecture 2 scripts. I click on open. All the data I want to use are already there. I click on open. You can see I have displayed everything. I'm using Arrow Markdown. You just open it from your studio. You don't have any problem opening from studio. It will come out in forms of chunks because I've written it in that format. The first one we want to look at here is read the data from the CSV file. How do we read the data from a CSV file? So we look at, we use read.csv. That is the first one I want to look at. What we have on the left-hand side, I wrote cricket.data. It can just be data. It can just be math. It can just be any name, just as I've said last week. What you have in your left-hand side is always a name that you have given yourself to capture what you want to put in there. If you look at the direction of the arrow, it's saying that everything on the right-hand side should be given to what we have on the left-hand side. So the code, the major code actually starts from read.csv. You open and close brackets. Now, cricket.csv is the name.
Please slow down. People, can we slow down, please, so that people can get it? Let's ask, how many of us already have the files downloaded on our system? Please, if you are, yes. I'm not yet, okay. People are not yet to do that. So let us signify. If you have the folder, if you have, yes, I can see. If you know you have downloaded it on the WhatsApp page, please put yes on the chat so that we can know, all of us can be on the same page. If we can only finish the scripting today, it will be better so that all of us will know we will get something. So if you've downloaded it on the WhatsApp, okay, I can see Isaac say no. So we are trying to put it on the Zoom chat too, so that you can also have access to it, because it's better we all have the same. If you are using your laptop, we must be on the same page. If it is only 1 or 2 people can grab it, I think it's fine. Rather than we are just talking and giving the slide, not yet. Okay, please, let's try and if this is not the first lecture, so for those of us that missed the first lecture, you can ask, we'll upload the YouTube videos. You can watch the YouTube videos. So that I know that it's just an introduction in the first lecture. So we are trying to see how we can add some of those files here. Just make sure you install R Studio on your laptop, then we can pick it up from there.
You should download all the data. All those data are important because you are using them as examples.
So let's start from, yes.
Okay. If don't open the file directly from the folder, open your studio first. Once you open the studio, you can now click on file, click on open file, then locate where you save. For example, if your work is on the desktop, you go to desktop, locate the folder. As I've earlier said, make sure that you create a folder for it. All the file downloaded should be in the same folder so that you can easily have access to it. Mine is on data analytics class. So these are all my files here. The files you will have are those ones you will need. They are all uploaded on the platform. Just download them on your system. Then this is the file I want us to open, lecture 2 scripts. Lecture 2 scripts. It's an arrow file. So once you click open, it will open. I've already opened mine. This is mine you are seeing here. So as I said before, the lecture has 2 legs. Today lecture has 2 legs. The first leg is how to bring your data first into R. Then you can now manipulate the data from R. The second leg is the data visualization. Different types of plots that you can think of. You can actually do them from R. And how beautiful it will be depends on your expertise, depends on your input. So I'm starting with CSV. I'm starting with CSV, data that are comma separated. So the keyword here is read.csv. I'm looking at 3 ways of importing CSV files. So I'm starting with the read.csv. The first thing you type on the left-hand side is, I can just say data, if I like. I can say data 1. If I like, accept decimal, I can say data.mat or data.equal, if I like. So it all depends on what you want to use. So in this case, I use cricket.data. I'm using cricket.data because I just want to show that the data is a cricket team. There are some cricket teams. The match is they won, they lost, and their points. So I just use cricket.data. Then the right hand side now, the read.csv is the keyword. Once you type read.csv, it will, you now put open and close brackets. The way I like you to type it, once you put read.csv, for instance, let me copy this one, or let me cut it and hold it. If you type read.c, you can see it's giving you option, but I'm using the first one, read.csv. It has open and close bracket itself. Ordinarily, I should be the one that will open and close brackets if I'm using R, but since I'm using the studio, the studio is smart. I will now just put, because I copied, I'll just put what I want to put there. So the first thing you have there is, okay, let me see remove it so that we can, cricket.csv is the name of the file. Okay, let me see. Cricket.csv. That is the name of the file. Then comma header true. Now the true is capital letter. Then sep equals to so with this you can run that chunk. What I want to get from this chunk is, I've turned all these ones to label, is cricket.data. I want to get cricket.data teams. I want to display the teams. If I run this one, the result will appear just below it. So what I've just displayed is a team where the team name is Nigeria. So if you run that, that's what will be displayed. Team, where the team name is Nigeria. We can as well, let me close this, let me block this, and let me attach let me attach cricket.data, meaning that it should let the data stay on this R console, so that each time I need it, I can always call it. And another way, another importance of the attach is to show you all the variable name. If I run this, it's showing all the variable names. In the variable names, I have lose. He arrange it in not the way it is, but in alphabetical order. That's why it's starting with lose, points, teams, wins. But the actual way of arranging is we have the teams first, we have the wins, we have the lose before the point. But you can actually see the variable names 1, 2, 3, 4. In this particular data, we have 4 variables. And you can see the spelling of the variables. You can actually copy the variable you want if you don't know the spelling, so that you don't do mistake. So that is it. Then we can as well look at cricket. We can as well print that cricket.data. As I said, if you want to print in R, we just type the name of the data or the name of the variable or the name of the object. Aru is very smart. You understand that you want to print it, you want to view it. So if I run this, it will give me the complete table, but it will show the first 10 values, the first 10 cases, or the first 10 observations. We have the teams. The team is character. We have the wins integer. The number of lose is integer. The points is also integer. So we have 10 of them showing. So if I want to click, if I click the next, I will see others. Now, let me collapse. If you click on this, you collapse that particular chunk. Now, if I want to view the first 5 observation, let me block this. I want to view the first. I want to see the first 5 observation. I will run this particular one here, egg cricket. If I run egg, let me remove this 2 here first. If I run egg cricket, by default, it will give me the first 5 rows. It give me the first 6 rows. The first team, which is India, to the 6th team, which is New Zealand. If I come back and say, okay, I want to see only the first 2, rows. If I click on this, it will give me Indian and South Africa. So just like my colleague explained yesterday in SQL, that you want to view a particular case or a particular observation or a particular, for example, it's an employee data. You don't want to view all the data sets. You just want to view for a particular employee. Then you can use this particular one. Cricket, this one. We have cricket.data. Now, the variable name teams is inside this cricket.data. We have done this last week. That's why I use, instead of me to just say teams, I have to put cricket.data $team. You can see what I want to call up is teams, but I have to use the cricket.data $teams equals to, this equals to is a logical argument.
Ekon, please hold on. People are not hearing you very well because your volume is too low, and you need to move closer to your camera, or you increase the volume of your laptop. That's one. Number 2, A lot of people are complaining because we need to recap. And I discovered that good number of us are not having the file you are working with because of the link. So I'm also in contact with Ogunsanya now. Let's add the link so that the people can also have the link to download these materials and be able to follow up with us. So I would advise, if you can recap the Cricut data sets while we are looking at how to sort it out to upload the link so that people can follow.
Okay.
If you can increase the volume of your laptop, please do that. Or your phone. I don't know the gadget you're using, please.
I'm using laptop, but maybe I will use phone for the volume so that
okay, that would be better. And make sure you mute the laptop. Okay. Then they said they need you to slow down.
Okay.
So that they can grab it. Okay. Thank you.
Recording in progress.
Let me introduce this one. Can you hear me now?
Perfectly.
Okay.
So you need to mute you mute the system and you.
System.
Please talk so that we can hear.
Okay. You can hear me now.
And we are still having the feedback.
Maybe they should quickly share download the material now so that we can go together, because everything I'm going to do is on that script.
Because
it will be on.
We are working towards that. So you can continue from the beginning while you take while we are working on the files. Ekun, please continue. Unmute yourself. Ekun. Well, Yemi, you can also work on R, but R Studio is more interactive. That's why we're using R Studio. It's still the same thing. On R Studio, you can see your library, you can see your pictures, you can see everything at the same time. The code can still work on both. Thank you.
I'm sorry.
Are you already teaching, sir? We can't hear you. Sorry.
We can't hear you, please.
Mr. Ikum, is anything the matter?
Hello, can you hear me now?
Yes, yes.
Hello.
We can hear you. It's clear, audible. You go on.
Okay. So if you want to continue from here, let's go to the working directory, because if you don't have the working directory, if you don't set your system to the working directory, you might not see all those files. You will not see all those files. So we click on section. Then you go to set working directory, choose directory. Can you see that? Let me go back again. Section, set working directory, choose directory. So my own is data analytics. Your own you can click on desktop and click the particular folder and click open. Mine is documents and clicking on data analytics class. Then I click on open. What I've simply done, I have set, if you look at the command prompts here, I've set my working directory to c/user/admin/document/data analytics class. So if I know this, I can just type this directly before I continue. But the way I've taught you now is the best way to do it. Click on section. Why I'm repeating it is because if you don't do this, everything I'm going to do, you might not have any relationship between your scripts and your data sets. So you set working directory, click on choose directory, then you click on the folder you are working from. Okay, having done that, we want to look at the first one, which is reading CSV data. We are looking at read.csv. You can just type this on your own. You can just enter and try to type it on your own. This cricket.csv, I'm just using cricket.csv so that I will know that this particular data is for cricket. I can type another, I can just say data equals to, and I continue. And I will say achieve the same thing I want to achieve, .csv. You can see it's giving me the option. That is the advantage the studio has over the arrow. If we click enter, it has open and close bracket for you. So what you just need to do is to put the data, the file name, which is cricket.csv. Then you put comma, the header equals to, now you use capital letter to type it through. Then sep.
Sir, just hold on, please.
Okay.
Please, can we all click on the chat, the Google Drive link that is there? Please click it on the chat, everybody, please. Especially those of us that have the, we are using our laptop. Click it and download. I want to see whether you have access to it. If you have access to it, all the file we're working with is there. Can we try it, please? If you can have access, please just say access give. If you have access, say yes. If you don't have access, say no, so that we can see whether the link is working, please. Can we quickly do that? The first person that have access, just put yes. You will see all the files there. Then you can download it in one folder and then you can set the directory like he's explaining. Please, we are waiting.
Hello.
I can see people have access already. Okay, then if you need anything on that, you have access already. So let's use that link. Thank you. So
Can I continue?
yeah, please continue. You can now please start from the directory. Now people have the folder.
Okay.
You can now start from the directory, please.
Now the folder, since you have downloaded the folder has all the files that you are working with. Copy the folder from the download. If you want it to be in download, that's no problem. You can copy it to a particular location you want to put it, either in the document or desktop or in any location of your choice. But just note the location you have placed the folder so that to locate it will be very easy. Now, we have to set working directories. If you are just working from Arrow Direct, like what we did last week, you don't need to set working directory. But now we want to link the script you are working with and the data sets. That's why we need the working directory. So go to the working directory, look at this menu bar. We have the file, we have the edits, we have the code, we have the view, we have the plot, we have the section. So it's the section we are going to click on. Then we have the set working directory. Then come to choose directory, click on choose directory. Mine is on data analytic class. Somebody own can be on desktop. Then you go and pick the particular folder on desktop. If this is malaria, you just click on malaria and click open. If your own is in download, just click on download, click on the folder and click on open. If your own is in the documents like my own, you click on data analytics. That is the name of my own folder. The name of your folder can be any name. It's not necessary to use the same name with mine, but just know where you have saved it, where you have the folder. Then we click on open. So if you look down where I have the command prompt here, you can see set working directory. That is the code. And the location is in C, in my hard disk, user, admin, documents, then the file name. So I believe we have all done this. If you have not done it, just try to do it so that, how do you know that you have done it? Just run this first chunk of code. If you don't see any solution like this, just know that you have not done it. So let me start with this first set of code. I just wrote this one on line 3 now. It's the same thing as the one on line 4, but I'm just trying to use it as an example that instead of typing cricket.data, you can just type data and you get the same result. So whatever you are typing on the left-hand side is your own name that you have decided to give the file you are calling. So you can decide to give the file any name. So that is what you have on the left-hand side. Then what you have on the right-hand side is the keyword read.csv. Then we have the name of that file. There are many files inside that folder, but we want to call up cricket.csv. We have some Excel file, we have some text file, we have different other files, but we are particular with this file, cricket.csv. You put it inside quotes, double quotes, then you use comma to separate it. We have header. Header is another parameter showing that the first line of that Excel file is, of that CSV file is the header. Maybe the name of the team, the number of goals they score, the number of wins, number of losses, and their points. So those one will show that yes, the first row is what? Header. They are not part of the data set. They are part of the data set, but they are the header of the data set. They are not part of the observations. Then we have the SEP, meaning that we are separating them by comma. Just like you copy a data set in your notepad and you want to paste it in Excel, it will not enter except you go through other means to copy it and put it in Excel. So by the time we run this, before running it, let's say attach cricket.data. Now, I'm not calling it cricket.csv anymore. What I'm calling it is cricket.data because that is the name I've given to it. So on this system, on this script now, on this program, it is recognized as cricket.data. So once I attach it, I can display it cricket.data. If I run this, let me cover this. If I run this, look at what I have here, cricket.data. If I run this, you can see this is the data. We have teams, we have wins, we have lose, we have points. You can as well load premiership table. You can as well load employment data. You can as well load any data you want to load, irrespective of the size. When we talk of big data can be big indeed. So the advantage Arrow has and Python over many other statistical software is that the ability to handle large data. Not only large data, either they want structured or unstructured, they can handle it. Either text file, no text file are not structured, they can handle it. So that is the advantage it has, just the way Python also has that advantage. That's why we use it for data science. So now you can view the results. It's showing the first 10 values by default. That is how to show it. If you click on next, it will show the rest 4. So meaning that we have 14 teams. So this chunk, the result, I can collapse it. So I've collapsed that particular chunk. But there are many other things we can discuss from here. Now, if you want to see the heading and some of the observation, you are going to use head. Let me block this. If I just put hash in front of it, it means that don't execute this line. So the 2 lines I'm executing, or the 3 lines I'm executing from this chunk is the cricket.data.
Sorry, sir. Engineer Franklin, yes, you raise up your hand.
Thank you very much, sir. Please, sorry to interrupt. I think you're very quite fast, and I tried doing what you did right now, and I'm getting error. I think we need to actually try what you are doing exactly, so we can actually follow up. Because truly, I did what you just did, and I'm getting on the shunt error in 5 out. Cannot open the connection. So I don't know. Maybe there's
sections. Have you gone through the section to set the working directory?
Yes, I've done that.
You have set the work directory to a particular folder.
Yes, sir, exactly.
And in that folder, you have this file, this script and this cricket.csv.
No. I don't have that file. That's not how I saved my own file name. That's not the name of the file I have. I didn't save it like this.
Let me show you. What I'm saying is that in that file, that folder you have downloaded, don't you have cricket.csv? Cricket. Don't look at it. You see cricket inside that file.
Okay, sir.
The one you have downloaded. Check. I'll wait for you.
Okay.
Just open the folder and see if you have anything cricket.
Sorry, sir. All I have there is the lecture 2 script. The file that I open right now, we open that into this R Studio. Sorry, sir.
Okay, you don't have the script. You don't have the Cricut. So it means it's only one file you have inside the folder.
Okay. Okay.
If you have only one file inside the folder, that means you don't have access to the data.
Oh.
The data is Cricut.
Well, let me copy all the files inside that place.
Copy all the files so that you can have access to the data.
Okay, sir.
Cricut is one of the files you see there. Just copy all the files because you will need all of them for this particular section, for this particular class.
Abidogun, can you please unmute yourself? Is it possible you join our studio so that we won't divide the classes, so that we'll be on one page, please?
Then those of you that are using
console,
it's a different way to set the working directory.
Aha.
It's not the same section I'm using now. Your own working directory will come from the file you see down there. Set working directory. This is a different way from the way I'm doing it from the studio. You still get the same result, but you have to set your working directory too as well.
Okay, okay, you're on R Studio now. So can you, Ekun, please display how they will run it from R Studio so that they will know. Yes.
If you go to your desktop, if you open your desktop, you see R Studio on your desktop. Just double click it. You have the 64 bits and the 32 bits. Sometimes the two will install, but just look at your system. Your system is 64 bits. Double click the icon of 64 bits. It will open this environment you are seeing on my screen now. These environments, you can see the file, you can see the edits, you can see the code. All those ones are on the menu bar. So click on File, then click on Open. Open File. Then, if it is on my documents, you click on Documents and locate the folder. My own folder name is Data Analytics Class. It's not necessary you have the same folder name with my own folder. You save a folder the way you think you can understand it. And there are different ways we organize our files. Some people might like to save their files on desktop. Some people might like to save theirs on the document. Some can even save it inside hard disks. So all those places are places you can save your file. You can save inside a folder and another folder. You can have multiple folders in the same folder. So whichever way you want to set it. So my own is Data Analytics Class. I just click on it now and I will open it. Click on Open. I will now locate the file I want to use. Okay, lecture 2 scripts is what I want to upload. So I'll click on Open and to open it. If you open it, you have something like this. This is what you have. Then I said the section. You go to the section, set the working directory, very much important because you have the file and you have the data. Unlike what we did last week, we didn't get data from other sources. All the data we got, it's either we type it ourselves or we generated it from ourselves. But now we are going to other sources to get the data. It's like we are importing data into R. So you have to set the working directory. So click on Choose Work Directory, and you come and click the working directory. The folder is inside Documents. Let me just decide to go to Documents. You click on Data Analytics Class. Then you click on Open. I have set the directory. Okay, if what you have here, maybe there are too many, you can just use Control A to clear the screen so that you can see everything. Then we go back to the same thing, section, set working directory, choose working directory. then open. You can see there, search working directory. My own is in C, user, admin, inside documents, and data analytics class is the folder I have specified as my working directory. So if I click on run here, it will produce the results, meaning that there is a relationship between the script and the file. So here is showing two cases, India and South Africa. What is this particular line is the line running. Cricket.data head show all the variables and the first two observations. That is the meaning of this cricket.data, 2. The cricket.data is the name we have used to collect the data. That means you have saved the data inside cricket.data. And now you want to see the first two observations. That's why we have used 2. If I want to see the first 5 observations, I will do 5. If I run this, it will show me the results, the first 5 teams, or what I call the first 5 observations. Also, if you want to look at a particular team, you don't want to display any other team but a particular team, you use this code here, cricket.data. That is the old data now. You now look at the variable that you want to use as a keyword to find. You say teams. When the team is equal to Nigeria. You know, yesterday we used where employee ID, it will fetch that particular employee. If you use employee surname as a keyword to search, it will show all the employees that have the same surname. That's why if you are creating a database, just like students, we have matric numbers. It's the matric number that is the unique identifier to identify a particular student. In this case, the team, you only have one team in a particular league or in a particular competition. You can't have Super Eagles and Flying Eagles in the same competition. No, Nigeria is Nigeria in the same. So the team name is like a unique identifier. Even if the team name is not unique identifier, if I say team equals to, you can see that it's double equals to. It's not like if this one equals to, it's not logical. Yeah, just like, but this one now is what logical. It's like you are saying greater than or equals to, or less than or equals to, or greater than. So in this case now, or you can say not equals to, but in this case now we are saying that where the team name or where the team is equal to what? Nigeria. Show the rows. That's why I put Nigeria and I put comma. Now it will show the rows. That is the meaning. Anywhere you have Nigeria, show all the rows that we have there. That is, if for example it's an employee, show all the particulars of that particular employee, not other employee. If I run this particular chunk, it will show Nigeria only. 5 wins, 2 losses, and 10 points. Now, if you want to look at other countries that you know that are there, let's say it's Indian there. Let me try if India is there. Okay. You run it. You can see this is for what? India. They have 5 wins, 2 losses, and 10 points. So just the way you can look for data, a particular case in a database, once you can have access to the database or to the table, you can easily manipulate it from R. You can easily pick a particular point, a particular value, a particular case, and so on. So let's move forward. Now, the second chunk. Okay, let me collapse this. You can actually collapse this output here. The second chunk is here. We want to look how to use the read.csv. What I have here is the same thing like what I did before. Let me go to the next one. Because of our time, because there are a lot of things we need to look at today. I want to do read underscore CS. Okay, let me come here. Let me use read underscore CSV. I want to use read underscore CSV. If I run this, it will give me results. But if you run it, you might not get results. These are not results. Why will you not get results? I have a library here, data.table. So I will use this opportunity to teach us how to install package. For you to use, for base R, you don't need the package to run the read.csv. But if you think that your data is so large that the read.csv cannot undo it, you now use your read underscore CSV. But for you to do that, you have to install this particular package called data.table. For you to install it, you can see there are 4 compartments here. We have this compartment where you have the script. We have the command prompt here. We have on that output table here. Then we have this pass. Just go to the package. We have files. We have plots. We have packages. Click on packages. Then click on install. Then you come to this place. You type data.table. You can see data.table. Just click on it and install it. Just wait for the installation to complete. I've already done all my installations. Just wait for the installations to complete. And once the installation is complete, you see it here on your cursor here. You see here on your the prompts here, where you have the command prompt there. This greater sign will show greater than this sign here that looks like greater than here, where you see my cursor here to show. And you will be blinking, meaning that it wants to accept something else. Otherwise, there is nothing else you can do until you get that. So you have to wait for the installation to complete. So let me continue. I believe we have all done the installation now. I have to slow down a bit so that other people can do their installations. So you click on the package, you click on install, then you just type the particular package you want to install, because you know the name of the package, data.table.
Ekun, please. Ekun, please. A lot of people are not following according to the message. So you need to, we need to still break it down more.
Okay.
So you need to break it down more.
Okay.
So my question is this: one of the things that I want us to quickly do in order to carry people along is, can you tell them, look at number 11 now, the line 11, what does it mean? What does how do we move from number 10 to number 11? Where do we run number 11? How do I know when I get there? Do you get the point now?
Yeah, thank you very much, sir. Thank you, sir. That is it.
Aha, you get the point now. So I'm just reading the mindset of people. I know it. Some of us know it, but what about people that are coming? Don't assume they know. Like inverted comma .r, what does it mean? When do we put it? Do I need to do that initially? Yes. From number 1 to number 11, where do we get, how do we get it? Then, sorry, you show us the file, the plot, the package. Where do we see, can we see the plot from the plot? How do I go about it? Thank you, sir. Over to you. Ekun, are you there?
Yeah, it's connecting.
Okay.
Okay. So if you look at my cursor, there is this particular, you can expand and collapse the output. By the time you click on it, it has collapsed the output. Ordinarily, it should bring something like this. But if you want to create another chunk, this is the end of this particular line 10. If you press Control Alt I, Control Alt I, it will give another chunk. Do you get it now?
What is chunk?
The chunk is just is subset, like what you have here. You can see this particular one. I can run it from, you can see this point here, run current chunk. I can run this particular set of code. I've broken the code into sub code instead of having all the codes together. If I run this particular code now, if there is a code that is in these other places, it will not run. It will only run between this. Look at this 3-dotted line. You have 3-dotted line before the arrow, and you also end it with 3-dotted line. And you can run from this place. Instead of running from here, you can run this particular chunk alone. So if you click on it, you're only running this particular chunk from this number 1 to number 10. Is what I'm running. So if you look at your own file too, your own script too, if you just run it, is that first set that will run. If you want to go to the second one, just scroll down. You see the second set here. This one starting from 11 here. This one here, I want to see how I can import this library, data.table, because I need it to run this line of code in this particular chunk. You can see where the chunk started. The chunk started from this place, from 11, and ends at line 18. That is using my own system, using my own script here, starting from line 11, ending at line 18. So if I run this line, if I run this chunk, which line we run? The library will run, the cricket.data2 will run, and the cricket.data2 printing it will also run. But this import data.table library will not run because it's a comment. Comments, the syntax for comment is hash. Once you put hash, it means that any statement after that hash will not run. Okay, look at this cricket.data2. I can put hash here and make a comment. This is the output of the data. Now, this comment is showing that cricket.data2 will run, but every other thing after the hash will not run. So that is what the comment serves. So in this particular chunk, the library will be executed. The cricket.data2 will be executed. Then this cricket, printing the cricket data2 will also be executed. We have how many lines there? We have 1, 2, 3, 4, 5, 6. We have 6 lines here. But
Okay.
out of those 6 lines,
Thank you,
only
sir.
3 will be executed.
Please, there's a question here. They said, what is the difference between data.table package and util package? Mustafa?
The data.table.
Yes.
Okay. The first one we did read.csv. We did not need any package to use read.csv. For now, if you want to be doing your work, just use your read.csv. You don't need any package. But you now need package if you want to use read.csv file that is large, very large. You now need to install this package. This data.table will enable the package, will help us to have this library, because without this library, this read_csv will not work. Read_csv is to import large file, very large file. But ordinarily just use read.csv. It is only when you discover that read.csv cannot pull the file from the source, you cannot use read_csv. But for you to use read_csv, you have to install the package. There are many packages in Arrow. They are all free. Only that you have data to install the package. That is just the disadvantage. So for you to run a package, you need data. But now that you are running with on data, because of the Zoom class, you can easily do that if you have data. But if you don't have data, never mind. The script is already with you. You can always run it at your convenience. You get it now. So the most important is that know how to bring the data to R. Now, if I run this particular one, if you run it for me, and the result is just immediately under it here. I have the teams here, just the same data sets. The same data set, we have achieved the same thing. So I don't need to dwell much on this. I will go to the next chunk. My own next chunk is starting from 19. If I run this one also requires the data.table, the F-read. F-read is used when the data is extremely large. When I talk about big data, is extremely large. That's when you use F-read. I'm still using to bring the same data set. Here, I name it as cricket.data3. If I run this, you still give me the output that I need. Is you still give me the output that I need. So from your table, you can manipulate this table. You can actually do any manipulation you want to do with the wins, lose, and points, their numbers. You can look at their regression, you can look at their correlation, you can look at their plots, you can do any manipulation. If you want to treat it as database, yes, I want to look at a particular set of observations. I want to look at the first 2 observations. I want to look at the next 4 observations. You can actually do that from these points.
Thank you, sir. Can you please go over the installation of data.table, installation of library?
Okay, let's do that now quickly. Let's look at packages. If you look at this section, you have 4 sections in this studio. The lower you will see the packages. You see packages. You see my cursor? Can you see my cursor? It's revolving around the packages. You click on the packages. Then you see install. You click on install. Then just type the name of the package. Data.table. dot table. Can you see it? It's already showing there. Just click on it and install. I don't need to install it again because I've already installed mine. So just click on install, it will install it. Just click on install, it will install it. You just need some data to install. And once it finishes installing, you will see your prompt here to show you. It will be blinking. It will be blinking here to show that, yes, I'm ready to take another line of command.
Yeah, Oladapo is asking, can we know the lowest points from the table alone? Is it possible?
Okay. Yes.
Okay.
You can know the lowest point from the table alone. Okay, let me do that from here. Let me do that from here. Okay. Now, let me run this particular chunk. Okay, let me go to the last one. We are here. Let me run this particular one. So I have my results here. Okay, let me come to this particular chunk now, which is empty, which I've created before. I created it the other time. If you want to create a chunk, just press Ctrl-Alt-I. Now, N, I want to get the length of the data set. This one, you can easily see it. But there's some data that is very large that you don't even know the length of the size of the data. Just type length. That is length. I'm looking at Cricut dot data 3, then $ teams. Remember what I taught you, what we did last week. Team, I want to look at this length of team, this particular variable. What is the length? If I run it, let me print the length. Because without typing N, if you only run it and just store it inside N. But if I run it now, it will show me that N is what? N is 14. Now that I know that N is 14, I can just copy this code that I have here. I can just come to this place. Now, I want to see. So it's now showing me the last one, which is Kuwait. Kuwait is the last line there. Is the last row.
Can you do it again, please? The process again, please.
What I've simply done here is, let me assume that it's a large table that I don't know the last observation. I simply type N equals to the length of one of the variables here. Because when we are looking, if you are looking at a database or a table has columns and rows. The columns are where the variables are, while the rows are where the cases are or the observation are. So the first line, the first row occupies the first variable. Let me look at employee, for instance. The first row occupies the particulars of the first employee. The second row occupies the particular of the second employee, maybe the surname, the other names, the gender, the maybe employee ID, the salary scale, the level, and so on. So each line is a case or what we call observation. For you to know the last observation or the length of the old data, just type length of that variable. My variable is teams, but I need to put the name of the data $team so that I can know that that is the variable I'm working with. So I now display the n. If I don't want to display the n, it's not compulsory because I don't need the n now. I just need the n to work here. So, but if I run this, now I now have cricket.data. I'm saying that in this data set, give me the last observation, the last. You can see that I'm using square bracket, not ordinary bracket, but it's a square bracket. We did this last week anyway, but if you want to see it clearly here, we have n, comma. It means that pick this particular rule and all the information in that rule. If I run this, it's giving me 14. Let me now say I want to see the let me just since I know that it's 14, let me say 13 colon 14 n. Since I know that my n is 14, if I say 13 comma n colon n and run this, let's see what it will give us. It will give us the 13th. Can you see us? See now, it's giving us the 13th and 14 observations. The last two observations, that's what it's giving us. But if you don't still know that it's 13, if you just put n minus 1, just put n minus 1, showing that is the one before the last one. If you run this, you should see give you the same results. You can see that it's 13 and 14. Prevention, if you know the index of the particular set of this, maybe you want to look at the first or the from 10 and 12, from 10 to column, okay, let's say 10 to column, 10 to 13. We use 10 column 13, comma. It will give you all the observation from index in 10 to what? 13. You can see. It will give you France, Austria, Kenya, and Zambia because they are located in 10 to what? 13. But if you want to get a particular country, you can use, let me block this. Let me not run this. If you want to look at a particular country, that is this particular country I want to get, you can use cricket.data3. Now, where teams is equals to, let's say, Indian. Let us run this and see what will happen. You can see, it will take you to Indian straight. It will not show you any other one. If you have 5 Indian, it will give us the 5 Indian. Okay, let me also look at this. Okay, what of if you want to look at teams? You want to look at teams that have points, that have above 5 points. Points greater than 5. Or let me say greater and equals to, or just say greater than 5. Teams that with 6 points and above. If I run this, teams that are 6 points and above, if I come here, it's only Indian that has 6 points and above. Okay, let me run teams that have, let's say 2 points and above points. So you can see all the teams that has 2 points and above. We have 12 teams with 2 points and above. If you want to see teams that have less than 4 points, you can see less than 4. So these are teams that have less than 4 points. If I want to see teams that have less than 4 or equals to 4 points, less than or equals to 4. If I run this, so I have teams that have less than or equals to 4 points. So we can actually use it in our company. You have your data set saved as CSV file in a particular location, and you want to look at the employees whose salary is below a particular, maybe salary is below 100,000. You can use it to sort them out. You want to look at employees who are male, you can use it to sort it out. You want to look at employees who are senior lecturers and above, you can use it to sort it out. You can actually use all these commands. They are simple commands, but you can use them to get a lot of results done. So maybe let me continue from here. At least you have done some manipulations that you can easily see. So let me now go to Excel. Some of us, we don't want to convert our data from Excel to CSV. We want to leave it as Excel the way it is. We want to save it as Excel. The extension for Excel is XLSX. So we have to load this package. But if you don't have data to load the package, just stay with what you have. But if you want to load the package, and one thing about the package is that once you have loaded the package remains. What you just do, just to call it using library to call the package anytime you want to use it. Just call it and you can use it. You don't need to install. It's not every time you want to use it that you install. Some people will look for an opportunity where they have data to just install as many packages as possible they know that they will need, so that by the time they start using it, they will not need to install it again. Now the package we need to install now is Read Excel. So let's install the package first. That is for those that are interested in installing the package. That if you don't want to use CSV, want to use Excel, you want to call your data from Excel. So you still come to package, click on install, and type the name of the package you want to install. Okay. Okay, let me go back again so that for those people that missed that part, this manipulation of data parts. Okay. This manipulation of data parts. Somebody asked that if you want to see the last observation, you just want to print only the last observation only. You don't want to print any other observation but the last one. I say first, you need to know the length of the data set. That data you have saved. What is the size? What is the length of the data? You can get that from a particular variable. Just know the name of a particular variable on that data set. It is the employee name or the employee ID. Just look for the length. It will show you the last observation. And then you can now use that N to look for whatever you want to run. Like what I did the other time, I just put N here. N. I type the name of the data. That is cricket.data3. Let me use data3. Cricket.data3. You know why it ran here the other time was because data, cricket.data, cricket.data2, cricket.data3, they are all the same data. I only show you how to use different CSV command. Here, cricket.data3. Look at it, this is a square bracket. N, comma, then close the brackets. If I put it the other way around, it's a different thing that you do. But what this one is saying that, go to the last observation. Show me all the particulars of that observation. Here we only have 4 variables. So the team, the number of wins, number of losses, and their points. It will show you for this particular, the last observation. If I go down, you will see Kuwait is the last observation or the last case in that table. And this is the particulars of Kuwait, the name of the team, the wins, the number of wins, the number of losses, and their points. So we can also use it if we want to know a particular, maybe a particular set of data, like where we did what we did here. I want to look at the team where the name of the team is India. It will just go and pick India. If a student comes to you and you are the database administrator in your school, and you want to use, instead of using SQL, and Arrow is what you want to use because Arrow is free, you can easily use it. And the student says, sir, I want to know my matric number, or I have my matric number. I want to know my score, my CGPA, because you don't want to show the students other people's CGPA. Just ask the student, what is your matric number? Because you know that matric number is a unique identifier. You can't have 2 matric number on the system. So what you do, you just collect the student matric number and you type the name of that variable, which is matric number. Just type matric number. Normally, if you are using SQL, say matric number, you type the data where matric number is so. But in Arrow, you just type matric number equals to India, equals to that matric number. That if the matric number is a number, you type the number. But there are some schools that their matric number is not actually number, it's alphanumeric. Maybe they have letter before the number. You have to put it in, you always have to put it in quotes. So if you, by the time you run this set of code, this particular one, let me close this one, because if you run from this and chunk, it will run everything. So the one you want it to display is the one it will display. If I run this, it will show me the result of India, because I say where the team name is India. So we just bring India. And you can also look at some set of data. Maybe you want to look at team that score below 4 points. You want to look at staff that earn below a particular salary. You want to look at staff that are about to retire, those staff that are above 60 years of age. You can use this code, just type age greater than or equals to the particular value you have there. It will give you the ages of all the staff that are below that. So I'm just using this data set as example. You can link to other data set that you have on your system. Just save it in that particular folder and you can call it. You can save it as CSV. You call it. You can also save it as Excel and you call it. So I think I've done justice to that. Anytime you want to collapse this, you can collapse it. You don't want to collapse this, you can go to the next one. Okay, the next one is not even the Excel, it's the test. The next one is the test. Now, you have data that is stored as a text. Now, this is not structured. Text is not structured. Maybe I have some line of poem. I have some lines of, I have a poem, which poems are in standards and in lines, or you have something you have written that are in lines. Maybe your, anything you have written that you write them. Normally, if you are writing, you write line by line, and it's in text. You save it as what? Text, txt.tsg. What you do in this one too, you don't need any package to run it. It's a poem. I always teach my children on mother, so I name it as mother.data. You can see now, so that I can differentiate it from cricket.data. That's why I'm using mother.data, just to know that this data is on mother. Then read.delimited, but just put read.delim. The name of the file is my mother.test. Then header first. It doesn't have header. So all the lines are important. So head, mother.data. If I display, let me close this one. Okay, let me close the last two. Let me comment the last two. Okay, if I run this, because I use head, definitely to show the first 6 rows. And the first 6 rows might be all the rows. So this is the song I have here. Oh my mother, 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 I love you. I drink my tea with my sugar. I eat my bread with my butter. I am my bed with my pillow. Oh my mother, I love you. So this is the song written in Notepad. So you can actually call it into R. If I want to look at the first two lines of the song only, I use head, mother.data, 2. This song will fetch me just the first 2 lines of the poem. Oh my mother, 7 times, and I love you. So the first 2 lines is what is going to give me. And if I run this one, this third one I put here, and I run mother.data 2, comma, it will give me same results. So this one will give me the second row, just like the one we have in table, but only that this data does not have a row and column like table. It only has rows. So tests are written in rows. You write your test from left to right, and to give you each row that you want. If I want to see the third row from this test, if I put 3 there and I run it from that poem, I will get the third row only. I drink my tea with my sugar. That is the third row of that poem. So you can see that you can actually bring your test data that you have set, maybe you have it in Notepad, you can actually read it in Arrow and actually manipulate it or view it. So the next one I want to look at is the Excel data. You have the data in Excel. This Excel, many people will be interested in this because most people, their data are stored in Excel. So we just use library read SL. But if you run this code, it will not run except you install that package called read Excel. To install the package, I will go through the steps again. You click on package, you click on install, and you type the name of the package. You see all the packages that start with read X. We have read SL, we have read SL, SB. There are two different packages. The one I need is this. Then I click on install. It will install the package for me. So after installation of the package, you can now run it. You won't say because I've installed the package, then I want to run it. No, you must always write the library, call the library. Because once you install the package, there's a particular folder in your C where you have the array itself being stored. Because when you install any program on your system, it will create a folder for you in your hard disk. If you go, all these packages are stored there. So if we now change the system, you can actually move all those packages to the new folder so that anytime you want to install, by the time you click on package, you click on install. Instead of installing from Tran, you can go and pick packages archive zip file. You now locate the particular location where you have your that packages. And most time it's always in C. You go and locate it where you have it. But we are not doing that now. We are not doing that now, but if you have your packages in your system, you can come to Arrow Studio and begin to look for the location of your package to install from. So we have the resources, we have the application, and we have but we are not doing that now anyway. So that is if you want to load from a package. Your packages are somewhere on your system. But for now, since you are installing from Tran, you will just type the name of the package you want to install and you install it. For those of you that are using Arrow that are not using Studio, it's a different ball game altogether. You have to go and install it. You set the CRAN first. After setting the CRAN, before you now do your installation of the package, there are two steps you do. Set the CRAN, then install the package you want to install. So I haven't done that. We now call the library.
Sorry, there is a question for you, sir.
Okay.
He said, what's different between bracket and square brackets? What make the difference between them, please? And Franklin, okay, go ahead.
Bracket is just, you use it normally. Anytime you are writing a function, you use brackets. I also use it for mathematical, just the way you use bracket in mathematics. You can use bracket in that way. Or you want to write a function, just the way I've written read Excel underscore Excel. I put it inside a bracket because a function, then I have a bracket to put other particulars there. But square bracket is used if you want to locate a particular location in the file. That's why I use square bracket. Square bracket is like I want to locate and say where, just where, like SQL that you want to use the where function and to get a particular thing. That's what the square bracket is used for, to locate a particular data set table. So that's where I use the square bracket. If I want to look at, for example, when I was doing that thing, it was square brackets I used, mother dots, I put 3 there. This square bracket means that it's an index of a particular table that I want to get. If it's a matrix or a table and I want to get a particular cell, I can just put 2,4 and so on. So let me continue. Okay. So there are many codes here that I actually wanted to look at. Then this is for the data. The data, you can see this one has 21. It has different rows, but it has many other columns. Can you see it? It has different columns, but it has fewer rows than columns. And there is still another data here. Just in this one, if you run it, this one will go and pick the data straight away. This one is a song, a lyrics of a song, and so on. We have different data sources that if you just run it, we have them on your system already. For this particular one, if you want to connect to SQL, you also have to install this package and make sure that the SQL light is running on your system before you can run this. Then we have, we also have, if you want to run from your, from your starter, you can also run from your starter. Let me put space here so that I can see this clearly. Sorry.
I think, Mr. Ekun, we need to begin it to
So
round up.
we have different files. I'm just trying to look at all the files we have. We have.
We can start from there in the next class.
Okay. We also have read CSV, how to locate. All this one, I'm just trying to look at data manipulation, how to manipulate data, 1:4, comma, and so on. Though most of them we have done it before. Then let us now come to data visualization. Time is almost 9 o'clock. If you run this, it will give you the
Don't let us rush.
Okay, maybe I will stop here, but I just want to run so that they will see all the plots I have available for them. I'll just run all through so that they'll see all the plots I have. This is multiple bar charts. Yes, this multiple bar charts. Maybe next week we look at all this. If I don't want to make it to be beside, if I put beside first, it will put it in column. I'm just doing this so that by the time we come next week, we know what we want to, you can see this one is no more by side. This one is not like column. So you can make it horizontal. This is your pie chart. This is your pie chart. Your pie chart, you can put it in percentage.
Mr. Ekun, I have a suggestion, please.
Okay.
Okay, so I want to say that every one of us should go and check the code. We have the code, we have the data. Let us go and check the code and begin to just try and run it, each of the code. So anywhere you are stuck, please, the platform is open. Screenshot it, put it on the WhatsApp group. Somebody will assist you. If it will take the person to phone you and you can go through it together, I think it will be better. You know, we have over 400 people on the platform, but don't bother yourself about it. Just make sure you screenshot it, that particular aspect, put it on the charts that you need help here. Let's go through it. Don't wait till next class. We only have 2 hours in next class too. And people, the way we grab things is different. So let's take it serious on your own. Please, the code is running, everything is running. You only need 1 or 2 guides just for you to know how to do this. He has a very robust material for us, that is the code. We can run it on our own, and from then, if you need any assistance, please feel free to put it on the platform. Screenshot it, put it on the platform, and 1 or 2 people can assist. Thank you. So do we have any question? If you have any question, please, or any suggestion, please raise up your hand before we only have 3 minutes to go. You're welcome, Adejumobi. You're welcome, Olawale. And let's just thank our facilitator today. I know R is not easy, and some of us will still need to go back to our statistics to be able to recollect what we are saying. But let's try as much as possible to have an open mind, ability to be able to learn, and those material, what is sent to us, indeed is huge material that we can work on our own. We just need to do that. We can only touch base some of those things in the class. The bulk of work is still lying in your hands. It lies in my hands. So let's try as much as possible to also take our time, please, and work on this material. When they are talking about data science, everything you put on that code, that's what makes you a data scientist. So let's try as much as possible to sit down. If it will take you to copy the code 1 by 1 to create another script for yourself, please do that. Just for you to know it, it's possible. So please, Ecom and others, we can only, give you the tip. What we are doing is just like you are in classroom and they say CA is 30%. 70% is, it simply means you can only get 30% of the class, 70% lies in your hands. So everything you put on that code, they are very important. Take it and run it chunk by chunk, and at the end of the day, if you are stuck, please don't keep quiet. If you are chunking one chunk, just leave it there, go to another one, run it. Probably in this directory you did not. It took me a while before I know how to also set the directory. It's not a crime. Nobody will teach you that one in the classroom. So let's take it one after the other. If it is only 3 lines you are able to grab today, is something. If it is only 4 lines you are able to get something today, is something. If they ask you any interview, you don't know the next interview you are going to have, you don't know any courses they will assign to you in your course, in where you are working, or you don't know what they will ask you. Do you know how to do this in R? So you don't know. So let's take our time. We have over 500 lines of codes where you can read, and he has done a great job for putting it in different chunks that it will make it simple. You know that you are running this particular one. And I would advise us, let us be making comments. Comment means just put the hashtag, put it there, write what the code is working for. So the next time you want to do something, you will know the line. Oh, I have the code that can do the back plot. I have the code that can give me the map. I have the code that can give me pie chart. I have the code that can give me scatter plot. So from then, when you know what each of the code is doing, it will be easy for you to be able to interpret. Interpretation when that comes to statistics. What does it mean? 0 lies to 1. What does it mean when it is 0.99? Is it okay? Is it this? Is it that? So from there, we'll be able to relate it to our studies. So don't worry, we are going to enjoy ourselves when it comes to this R. You are going to learn a lot. And don't forget, this class, people will be coming from one point to the other. Every class, so we'll be having new people that will be joining. So it will drag us a bit. And I still want to encourage us, don't be disturbed, don't be knocked out. Just make sure you put your mind there and make sure you have access to the Google Drive. Please run it on your own. Just run it chunk by chunk, chunk by chunk. And at the end of the day, I believe you will grab one or two things. And we can also relate it to our own study. All you need to do is put your data there inside the same folder, then name it, run it, and it will work for you. Thank you so much, guys. Ekum, is there any other things you want to say?
Well, I just want them to go through the files, run them one after the other. If there is anyone they need to install a package, they should install the package and run it, and they will get the result for everything they have done. They are running, because all the codes I've tested, all the codes they are running, except for the one that have packages. They should just install the packages and run them. And once they do that, just the way I'm running it now, the result will come out. So you can adapt the result to suit whatever you want to do. Which if it is you are working on map, all these ones now, they are maps that I've been working with on. You can always get the result of the Google map. Once you do everything I ask you to do, just go through the PDF, gently go through the PDF, then come back to the script and run all the lines, all the codes I have here. It will be executed chunk by chunk. Any chunk that is not running, just go to the next chunk and run it. The ones, it's not all that requires packages. The ones that require package, install the packages or the particular package and you run it, and you get the solution to everything you are doing. That is beautiful. There are many things, but I thought we were able to touch this today so that by next week, I will just go to data analysis, your ANOVA, your linear model, your chi-square, or the data analysis proper, so that the last week we cannot go into machine learning. Not necessarily deep into machine learning, but at least you start with your linear model, your binary logistic regression, and other regression model, other predictive model that we can use. I think by the end of the class, I would prepare the notes. Even though we would not cover it, you have access to all the materials and everything that you need to know concerning this particular program we are doing now. I think that should be enough for now. But all what we are going to give to you, as you have stated it, today we have done how to attach and get data from other sources and data visualization. Next week, we look at data analysis as a statistician that wants to analyze data, or as a user of statistics that wants to analyze data. Then the last week will now be on machine learning, data science purely, how you write machine learning code from R. I think that will be sufficient for this particular section of training. Thank you.
Okay, thank you so much. Last but not the least, I quickly remember something. I want us to have the mindset. There are two ways. Remember, we are learning SQL. The difference between SQL and R programming. Please don't bring the same mindset. SQL is a database stuff. You see, the way the guy that was Mr. Babatude, when he was explaining to us yesterday, is quite different from this. So when you are doing SQL, there are different minds for SQL and what we are using now. This is programming. And
they should note that SQL, Dr. K, they should know that SQL works for structured, it's a structured query language for tables, any data that is stored in rows and columns. But Arrow can access either it is rows and columns, either their songs, either their text, either from any file. either it is SQL or no SQL, like your MongoDB and any other non-SQL, how can work with it. So that's just the difference. SQL is mainly for structured data that are structured, that you can easily locate the row and the column. That is
It's already after 9. It's already after 9, please.
So
Okay,
thank
so
you so much. And see you guys
sorry,
next
sir,
class.
Dr. Okay, before I learned from the SQL guy, he said it will be available on Wednesday, 8 to 10, 8 to 9. If you have any issue you want him to resolve before the next class. And if you have any problems too, you can also go to the administrator. You can access any one of them for them to support your work. If there is any 1 or 2 issues you want to solve, you can go to the administrator on the platform, talk to them, and I believe that they will respond to you. But let it be in the evening between 7 and 9. Thank you. Thank you, sir, Dr. Oked.
Okay, guys. See you guys next class. Bye for now.
Thank you. Bye.
Thank you.
Yeah, thank you, sir. Thank you.
Thank you very much, sir.
This man, oh wow, okay.